how to draw a circuit explaining the resting membrane potential concept. Okay. Now, a very important point we need to understand is this, that before we draw this circuit, we must understand what are the components of this circuit. Before we draw this circuit properly, we must understand that what are the components, single components of this circuit. Now listen, we will start with, actually, suppose this is a cell having potassium ion, okay, having potassium ion. Now listen, if this is a potassium ion, then you must understand that potassium will generally move out, right, also move in. But why it should generally move out? Because the concentration gradient is towards this side. That means there is more amount of potassium in the cytoplasm than outside. Therefore, potassium must move in. Now listen with all your attention. Suppose you want to draw this potassium ion. Now listen. If you want to draw this potassium ion using electrical circuit components, how can you draw this? Now listen. A channel is like a conductor. Okay, now listen with all your attention. A channel is like a conductor. Okay, why it is like a conductor? Why it acts like a conductor? Because it helps in passage of ions. Clear? That's why it's a conductor. Now listen, a very important point you need to understand is this, that what do you mean by conductivity? Conductivity is nothing but inverse of resistance. Now, how can we draw resistance? This is the this is the standard method of drawing resistance, right? In a physics circuit diagram, you can draw resistance like this, right? You can draw resistance like this. Now, very important point you need to understand here. That is, if I want to draw this particular scenario right now, suppose if I want to draw the role of potassium ion right now, then what I will have to do is, this is my potassium channel right now. Now listen, why it is my potassium channel? Because this resistor is actually now behaving like a conductor, okay? Because 1 by resistance is equals to conductivity. Now listen with all your attention. If you add many potassium here, then do you think this potassium efflux will occur? No. That means in that scenario, potassium channel will act as a resistor. That means it will not allow the potassium ions to leave, right? Now listen with all your attention. If I tell you that if potassium ion behaves like a conductor, then current must pass through it. Right? Current will have to pass through it. Now listen, suppose if I draw a simple circuit here, okay, the current across this resistor is due to this voltage or this potential difference created by this battery. That means due to this battery, current has been generated, right? Due to this battery, current has been generated across this resistor, right? Now listen with all your attention. What is the most important thing here? The most important thing here is this battery, which is actually creating the current or potential difference due to which current is flowing, right? Now a very important point is this, in this particular scenario, what is the battery, or who is actually playing the role of battery? Why we need a battery in this case also? Because we know that ions are moving in and out. That means current conduction is taking place. Now the battery in this scenario is the electrochemical gradient. Okay, the battery in this case is electrochemical gradient. Now listen with all your attention. This is actually your ion channel. That means, what is an ion channel here? Ion channel is a conductor with an electrochemical gradient. A conductor with an electrochemical gradient. This scenario is shown by this particular circuit, okay? Now listen with all your attention. Okay. Similarly, like this, we can draw sodium channel, potassium channel, right? Now, let's join them one by one. Okay. Let's join them one by one. Okay. This is just a short story, that is, suppose if I tell you that up to this stage I have drawn potassium channel, sodium channel, potassium channel, sodium channel and chloride channel, then which is the sodium channel, which is the potassium channel? Now listen, potassium is moving in or out? Out. Suppose this is your potassium channel. Okay. Sodium is moving in or out? In. This is suppose your sodium channel. Okay, like this, and it is like this. Okay, now this is your chloride channel. Now listen, who is maintaining the electrochemical gradient? Sodium potassium pump, right? Sodium potassium pump. Now we will have to add this sodium potassium pump here. Okay, these are your sodium potassium pump. Okay, these are your sodium potassium pump. Now listen with all your attention. So 3 sodiums are moving out or in? 3 sodiums are moving in, sorry, out, and 2 potassium is moving in, right? Now important point here is this, that we are actually forgetting when we have drawn this thing. Now listen, so this is your potassium channel, okay, K plus channel. So we have drawn it here. This is your, suppose, sodium channel. Okay, we have drawn it here. Okay. Now, okay, let me draw with these colors. Okay, then you can understand. So this is your sodium channel. This is your potassium channel. Okay, this is your potassium channel, and this is your chloride channel. Okay, this is your chloride channel, and this is your sodium potassium pump. Okay. This is your sodium potassium pump. Now suppose this is your alpha beta, right? Alpha beta. Okay, 3 sodium and 2 potassium, right? K plus, Na plus, Na plus, Na plus. Okay, clear? Clear? Now very important point you need to understand is this, what we are forgetting. We are actually forgetting a very important point, that is the membrane capacitance. The membrane capacitance we are forgetting. Why? Because you know what is a capacitor? A capacitor is actually a device, an electrical device, which actually is storing, which actually is used for storing charge, right? How can it store charge? Because it has a separation. This is actually gap. There is a gap between two capacitor plates. Okay, now one of the plate is charged positive and another plate is charged negative. Okay, now a very important point to understand is this. Now why we are comparing this capacitor with our membrane? Because across the membrane also we find this type of charge distribution, right? Across the membrane. Therefore, we compare this cell membrane with a capacitor. That's why we will have to add a capacitor to this system. Okay, then our circuit diagram is over. We will have to add a capacitor to it. Okay, so adding a capacitor to it, then we have got our this is nothing but this capacitor actually shows membrane capacitance. Okay, membrane capacitance. Okay, so this is the electrical circuit diagram of your cell membrane, and from this circuit, now listen with all your attention. There are many calculations. We are not going into details, but something you must know. Some calculations you must know. It is better for you. Okay. Now listen. Suppose if I tell you what is the conductance of all the what is the conductance of all potassium channels in the cell, then what will be your answer? Your answer should be conductance is equals to 1 by resistance, right? Important point here you need to understand is this, that suppose if I give this conductance a new name, gamma, okay, gamma is conductance of potassium. Now can we calculate the current? Can I calculate current from this scenario? Yes, we can calculate current. Why? Because from Ohm's law we know V equals to IR. Put this I, or make this I the subject of this particular equation. I is equals to V by R. Now listen, this is actually equal to V into 1 by R, that is gamma K, right? That is gamma K or conductance, right? V means what? Membrane voltage, right? That means current passing through these channels, we can find it easily. Membrane voltage into its conductance. Clear? Now, this is actually the current produced by one and only one channel. Now, if you want the current for all the potassium channels, suppose, then IKT total current is equals to Vm into, now listen, this is the conductance of a single channel. Now conductance of total potassium channel is equals to gamma K into N. N is the number of potassium channel, K plus channel, right? So therefore gamma K into N. Okay, so this is your total current passing through a single passing through all the single type of channels present in the cell. Now utilizing these theories, we can actually calculate the membrane potential, that is minus 70 millivolt. We can calculate using this circuit. Okay.